Quick review of the Pythagorean theorem. It works for right triangles. Here's the formula. C is the hypotenuse. The hypotenuse is the longest side, which is the side opposite the 90-degree angle. What you can do with the Pythagorean theorem is if you have A and B, you can figure out how long the side C is. And you go through this formula here. Okay, that's the Pythagorean theorem. We can use the Pythagorean theorem to figure out the distance between 2 points on a coordinate plane. To do that, we just notice that the distance from here to here is just x2 minus x1. And the distance from here to here is just y2 minus y1. And this here is a right triangle, which makes this a hypotenuse of a right triangle. And so now we just take these, plug them into this equation using the same Pythagorean theorem, and we can figure out how big PQ is. Here's the app. What this app does is it uses the Pythagorean theorem for facial recognition. So what we have here are 40 different people, and each of these people have 10 different poses of their face. So I'll click on this person, and I'll get the 10 different poses. Then I'll click on this person, and I'll get the 10 different poses. Now if I click on any of these 10 poses, what the computer will do is go through what amounts to 400 images and finds the 10 closest. So what do we get? Okay, so these are the 10 closest. Now the ordering here is this is the closest, this is the furthest, but you notice that it doesn't always make a match, especially as you get further down the list. Green means good, red means it's the wrong, that's an error. So these 5 altogether match the girl, but it goes in this order: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now if I pick one of these, what it's going to do is come up with the next screen, which is how the computer sees it. It'll be the resolution that the computer is looking at these pictures. Okay, so this one over here is the original picture I clicked on, and this is the one that I chose out of the list of matches. Okay, now I went back to the higher resolution for us to look at, but I want to go back to what the computer does. Now what the computer's looking at here is an image that's 23 pixels in this direction and 28 pixels in this direction. And what it actually does is it takes these pixels, this is pixel number 1, this is pixel 28, this is pixel 29, this is pixel 56. It takes each one of these columns and stacks them on top of each other until you get one long string of pixels, which is thought of as a giant coordinate. And then it goes ahead and uses the Pythagorean formula to go ahead and find the distance between these. So it compares corresponding pixel to corresponding pixel. So the square difference between these two pixels is 196. The square difference between these two pixels is 324. The square difference between these two pixels is 5329. This is the actual value of the pixel, this 84, that's the actual color of it. This is the actual value of this pixel, and that's the actual color of it. So what else can we do with this? Well, I can actually just look at, I just want to look at pixels that have a square difference that's greater than 4329. And so it blocks out everything else, and I can play around with it. So it allows a little bit of data analysis to do. So the students are not, they're learning about an application of the Pythagorean theorem. They can do some data analysis. But what's really cool about this whole idea, I think, is that they get to use, these faces will not be the faces they're going to use. They're going to actually put in their student faces. And so they'll take pictures using an iPhone or an iPad, upload those pictures to the app, and the app will work with their faces. So they'll be able to fool around, make faces, they can goof around and have some fun while learning an application of the Pythagorean theorem and hopefully remembering the Pythagorean theorem.